So far, we've learned two different types of transformations. Do you remember what they are? That's right, reflection and translation. These are called rigid transformations because the shape does not change in size. It's like a copy-paste sort of situation. Another type of transformation is called a dilation. This type of transformation is called a non-rigid transformation because the size of the shape changes, but the overall shape remains. So if you started with a square, you're going to end with a square. If you started with a triangle, you're going to end with a triangle. Have you ever gone to the eye doctor and gotten your eyes dilated? Well, I wear glasses. I've been wearing glasses since I was 3, so get my eyes dilated all the time. And what that means is the size of your pupils actually changes. That is what dilation means. So the size is changing when we have the transformation of a dilation. To begin, we're going to write the coordinates of this rectangle right here. It's called the pre-image because that's what we're starting with. And then the transformed shape is called the image. So the coordinates of A are 3, 2. B is 3, -2. C is -3, -2. And D is -3, +2. The first image we have is to dilate by a factor of 2. Okay, that means we need to take every single coordinate point and multiply it by 2. 3, 2 multiplied by 2 will be 6, 4. 3, -2 multiplied by 2 is 6, -4. 3, 2 times -3, -2 would be -6, -4. And 2 times -3, 2 is -6, +4. Let's plot those. And don't forget to label. This would be A prime, B prime, C prime, and D prime. They've asked us to dilate the image by a factor of 3 now. So we take each coordinate point of the pre-image and we multiply it by 3 to get the new coordinates. So 3 times 3, 2 is 9, 6. Continue. Let's go ahead and plot those points. And we're going to label these with 2 apostrophes. So A prime prime, because it's all in the same coordinate plane, B prime prime, C prime prime, D prime prime, or you can call it double prime. Our last dilation is by a factor of 1/2. So this time we'll multiply all of the pre-image points by 1/2. 3 times 1/2 is 3/2. 1/2 times 2 is 1. Continue. Now this one's going to be a little bit trickier to graph because we have fractions. So sometimes when you have an improper fraction, like 3/2, it's easier for us to mentally see it or visualize it when we write it as a mixed number. So 2 goes into 3 one time, and there's 1 left over, 1/2. So 3/2 is actually 1.5, or could be written as 1.5. I've rewritten my coordinates as decimals just so that it's easier for me to graph. A triple prime is at 1.5, 1. So I'm going to go to where 1 is and where 2 is. I know 1.5 is halfway between 1 and 2. So I'll go about right here. And then up 1. So your point is actually going to be in between the squares. Halfway in between. 1.5, -1. That one will be right here. Then we go to negative 1.5, which is in between negative 1 and negative 2. And we plot those 2 points and connect the dots. I want to talk about something I find really interesting about dilations. You don't necessarily have to put this in your notes, but just listen very carefully. What are the side lengths of AB and AD? Well, this side length right here is 4 units, and this side length right here is 6 units. Okay, what about A prime, B prime? This side length, 1, 2, 3, 4, 5, 6, 7, 8 units in length, and this one, 12 units in length. The orange rectangle was dilated by a factor of 2, and look at those side lengths. 4 times 2 is 8. 6 times 2 is 12. Ooh, I wonder what the side lengths of the blue rectangle are. Go ahead and count. That's right, they're 12 and 18. 4 times 3 is 12. 6 times 3 is 18. So what do you think the side length of A triple prime, B triple prime is? 4 times 1/2? Is that 2? That side length is 2, and if you count this half plus 1 plus 1 plus a half, that makes this side length 3, and 3 is 1/2 of 6. They want us to dilate by a factor of 3/2 about the origin. All of our dilations are about the origin. The coordinates of the pre-image, so what are the coordinates that you see right here? Go ahead and write those down. And if we're dilating by a factor of 3/2, we're going to multiply every one of these coordinate points by 3/2. You can reduce before you multiply, or you can multiply. So if we multiplied first, that would be negative 6 over 2, which is negative 3. Or we could see that 2 over 2 is just another form of 1, and that would be 3 times negative 1. So negative 3. 3/2 times negative 1 is negative 3/2. 3/2 times 0 is 0. 3/2 times 2. That one's a little bit easier. Again, we can see that 2 over 2 is just 1, so you have 3 times 1 is 3. V prime, 3/2 times 3. That's 3/2 times 3 over 1, which is 9 over 2. 3/2 times negative 2. Ooh, we already did that, so that's negative 3. And now we're going to plot these points. Negative 3 comma negative 3/2. Ooh, what is negative 3/2 as a decimal? That might be a little bit easier for us to graph. We know that from last time that 3/2 is 1.5. But what about 9/2? 9/2, well, 2 goes into 9 4 times, and then there's 1 left over. So that is 4.5, or 4.5. I think those will probably be a little bit easier for us to graph. So negative 3, negative 1.5. Remember, that's between negative 1 and 2, halfway between. 0, 3. 4.5 is about here, and then down 3. Go ahead and connect the dots. And do not forget to label the points. This is T prime, U prime, and V prime. Our first step for number 2, dilation of 2, would be to write down the coordinates for the pre-image. Dilating by a factor of 2 means multiplying every single one of these coordinates by 2. Ooh, that's going to be a little bit easier since it's not a fraction. Go ahead and fill those in and then check. And then let's plot them. And connect those dots. Our next dilation is a factor of 5. First, we're going to write down the coordinates of the pre-image, multiply all those coordinates by 5, and then graph the image. I want you to practice this one on your own, and once you're completely done, then click continue to check your work. And there you have it. Our last dilation is 0.25 about the origin. If we're going to dilate this by a factor of 0.25, is the image going to get larger or smaller? 0.25 is between 0 and 1. As a fraction, it's 1 over 4. So the dilated image will be smaller than our original here. Begin by writing down the coordinates of our pre-image seen here. To dilate by a factor of 1/4, we're going to multiply each of these coordinates by 1/4. 1/4 times -2 over 1, we could actually reduce that before multiplying. 2 over 4 is 1 over 2. So we multiply 1 times 1 on the top is just 1, and then 2 times 1 on the bottom is just 2. And we had a positive times a negative, so that should be a negative 1/2. What happens when you multiply 1/4 by positive 2? Well, that's going to give me positive 1/2. 1/4 times -3 over 4. We can't reduce 3 and 4, so we're just going to multiply straight across. 1 times -3 is -3. 4 times 1 is 4. -3/4. So the coordinates of S prime, 1/4 times -2 is -1/2, and another -1/2. Then we have 1/4 times -3. That's -3 over 4. 1/4 times 0 is 0. 1/4 times +3 is +3 over 4. -1/2. Then we have +1/2 and +3 over 4. Remember that 3 over 4 is less than 1, so it will be less than 1 unit when we are graphing. Let's go ahead and graph those. -1/2 and -1/2. I'm going to write in these values because that's going to help me a little bit. -1/2, -1/2 is right in the middle of that grid square. -3/4, comma 0. -3/4 is almost to 1. 3/4, comma -1/2. So we go 3/4, -1/2, and 1/2, 3/4. Not quite up 1. Ooh, it's an itty bitty shape. Okay, and that's a dilation of 0.25 or 1/4. To recap, a dilation changes the size of the shape, but the overall shape itself remains.